Good morning, friends. Today we are going to see about a very important topic of organic chemistry, that is carbonyl compounds, aldehydes and ketones. In this lecture, we will learn about introduction about the carbonyl compounds, how their reactivity will be there, their nucleophilic addition reaction, electromagnetic effect, etc. So now, first we will learn about what are carbonyl compounds. So the carbonyl compounds are molecules which contain a carbonyl group, that is the group which contain carbon double bond oxygen. Now if you see, the carbonyl compounds cannot replace a nucleophile because they have proton or alkyl group. So they will undergo electrophilic substitution reaction, but they themselves act as a nucleophile. This include the carbonyl group includes the three groups. One is a aldehyde group, second is a ketonic group, and third is a acyl group or carboxylic acid derivatives. Now if you see, the carbonyl group with OH is a carboxylic acid, and carboxylic acid OH, H is replaced with alkyl group, it is converted into the ester, whereas if this carboxylic acid dimerizes by losing of water, it forms acid anhydride. Whereas in the acid OH is replaced with chloride, it is a derivative called as a acid chloride. Whereas acid bromide, if it is replaced with amine, it is a called amide derivatives. And if it is replaced with the secondary amine, it is amide and tertiary amides. So the carboxylic acid also contain carbonyl group and they have different derivatives. Now, what are the properties of aldehyde and ketones? Because this functional group has a characteristic properties due to that they are unique and being considered as a separate class of compounds. So aldehyde and ketones are polar molecule because they contain carbon double bond O, oxygen. So this carbon oxygen double bond is a polar bond because oxygen is a more electronegative and carbon is a less electronegative. That's why the electron move toward the oxygen. Therefore, this carbonyl group or carbonyl bond is a polar bonds, and the compound which contain the carbonyl group like aldehyde and ketone act as a polar molecules and they have a dipole moment, means they have a positive charge and negative charge due to that they have the dipole nature, diionic nature. Now due to this, their polarity means aldehyde and ketones polarity are higher, therefore they have the high boiling point with compared to alkenes which similar to their molecular weight. Aldehyde and ketones are not hydrogen bond donors, they cannot donate a protons. They only eliminate the protons or release the protons. Therefore, they have lower boiling points than alcohols of similar molecular weight. So, with compared to alcohol, they are lower molecular point compound because they don't have the proton to release. Aldehyde and ketones are hydrogen bound acceptor. That makes them to have considerable solubility in water. That's why aldehydes and ketones will be soluble in water due to their acceptor nature. Now, if we see the reactivity of the carbonyl compounds, so the carbonyl compounds are highly reactive, or we can say the reactivity of carbonyl compounds is due to their polar nature, polarity of the carbonyl group, because oxygen is more electronegative than carbon. Therefore, the carbonyl carbon is act as an electrophile, and whereas it can be attacked by a nucleophile very easily. So due to polar nature, due to electron negativity difference, oxygen will have negative charge and carbon have positive charge. That's why it acts as a electrophile and the nucleophile will attack. That's why carbonyl compound undergo nucleophilic addition reactions. Therefore, carbonyl compounds undergo nucleophilic addition reactions. So, this polarity structure is given. Oxygen has partial negative charge, whereas carbon has partial positive charge. Now, if you see the general nucleophilic addition reaction, so an aldehyde has greater partial positive charge on its carbonyl carbon than that ketone. So, if we compare to ketone and aldehyde, aldehydes are more reactive because they have the proton, and ketone has the less reactivity, or they are less polar with compared to aldehyde. Now, if you see the reactivities, so in the reactivity from ketone aldehyde to formaldehyde will increase. Means formaldehyde is more reactive than aldehyde than ketone. Whereas the reactivity, if you see in ketones, so as the alkyl group will increase, the reactivity decreases. So acetone is more reactive with compared to methyl isopropyl ketone and diisopropyl ketone. So as the alkyl group in ketone will increase, the reactivity will decrease. Now, steric factors contribute to the reactivity of aldehyde. So we can say in aldehydes, if you see the substitution is more crowded, reactivity will also be affected. The carbonyl carbon of an aldehyde is more accessible to the nucleophile because it has only one group and other group is a proton. That's why it is a more reactive. Now, ketone have a greater steric crowding in their transition state, so they have less stable transition state. So, ketone, due to presence of two alkyl group, they are crowded. They are surrounded carbonyl group by two alkyl group. We can say it is a more crowded. That's why they are less stable transition states. Now, ketones have greater steric crowding because they have both alkyl aryl group both sides, so they have the more steric crowding or steric group presence. Therefore, their transition states have less stable transition states. Now, if we are see in ketones, the carbon has sp2 carbon, and the coming nucleophile will attack at the carbonyl carbon, and the oxygen will move, the electron move to the oxygen, and we will get the alkoxy group, oxygen with negative charge with sp3 carbon, and then this will undergo protonation. So addition reaction will take place in ketones and aldehydes. Now these ketones undergo protonation also, acidic condition, and they will undergo oxonium ion formation, and this oxonium ion is attacked by nucleophile, and we will get the alcohol. So both the routes can be possible. Base can be catalyzed or acid catalyze addition reaction, nucleophilic addition reaction on the carbonyl compound, that is ketone. Now in next class we will see the detailed study of the nucleophilic addition reaction.